Okay, I think we should get to continuing in the second part of today's lesson. And basically right now what we're going to do is continue working our way through this data processing part of the lesson. And then after that we will talk about errors and our good coding practice for today and debugging before we take a look at the exercise. So we still have some stuff to do. But where we left off was with this task you had, and that was to create a new column called month that contained only the month from our date values that were in the time str column. So we can do this by doing, for instance, data, and then we'll give our new column name, which is month. And we can say that this is equal to data. And again, we use our time underscore str column here. And then we can do the str slice approach. The difference here is that we don't start with the character at position 0 because that's the start of the year, but instead at position 4, and we stop still at position 6. So that'll give us, skipping over the first 4 things for the year, then just the month. And if I'm not mistaken, that should be all we really need to do here. So if you run this one, what you should get now, if we check our result and we look, for instance, at our data month column, and actually, why don't we do it like this? Let's put a Python list in here with our year month. Oops. Year underscore month. And our month. Like that. And if we run this one, this way you can see the month, but you can also see that the year is here. And yes, it looks like it's getting the correct month from that character string. So it is possible then to pull out just the month if we want. We could pull out just the day. Of course, that's a little bit weird because you'd have a lot of overlapping days in different months, but it's possible to slice things up however you like. There is an optional topic in this week's lesson about a new data type we haven't used before called Datetime. And well, I guess we won't run through this in any detail here, but essentially it's a way to represent things like dates in a separate data type that is specifically designed for representing things like date. And we can use this toDatetime function to convert something like from our time str column to a value called date in our data frame. If you run this, it takes just a second or two to do that. And if you run the cell underneath it, you'll see now here is our date, but in a format that looks a little bit more like a typical representation of a date on a computer, which is to say that there's the year dash the month dash the day, and then something that looks much more like the time on a clock that we have the hour colon the minutes colon seconds. So this is our date time format. What's nice about it is you can do things like this, where you can take our date and then do .dt, which is our datetime accessor, and then year, for example, and that will pull out just the year from our data set that we're working with. You could do the same thing with month, and just if you run the cell, you'll see that you get only the month for each one of these dates. So that's kind of handy. You could do things like stacking in the nUnique function, so you could take the years and see how many unique years do we have in our data set, and you see there's 51. So I'm not going to go through this in detail, I'm just kind of showing you what you can do with it, and you can read over the things on the course page if you're curious. But you could make a year, month, date time column, for example, by running this one, and what that does is it just converts something from, in this case, by giving a format string, we get the year and the month as the things that we want stored. And if we look in our year month dt column, you'll see that the day is set to be the first of the month for each one of these months. But this is something that's a little bit it's convenient in many ways to work with, but it's also a little bit trickier to work with, so we're just going to stick with the string slice approach for right now. But if you're curious, yeah, have a look over the course materials on the course page at a little bit slower pace so you can see exactly how this works. Yes, okay, yeah, because this is basically a function that's built in. It's not something that's part of the data frame itself. So like when you have a data frame, you can do the certain kind of built-in functions, like when we do .describe, that gives us the descriptive statistics for that data frame. But here we're actually using a function from the Pandas library that's not specific to our data frame. So this is like the toDatetime function. Its expectation is that you're going to pass in a Pandas series or a Pandas data frame, and it will then work on that. I don't know if I can think of a good equivalent to what this would be like. I don't think we've dealt with too many things where we would have had to use this kind of approach, but you'll notice sometimes that some of these functions are things that are kind of part of the like inherent structure of a data frame. So like the .describe is something that would be a common operation you're going to want to do with any data frame. ToDatetime is kind of a specific thing that only if you're working with data in the data frame would you want to use that. So I think the idea is that they kind of keep that as like a separate function you can use when you want to work with date type data, but otherwise it's not kind of a generic thing that's assumed you're going to do with a data frame like describe would be. Maybe that's the best reason I can sort of give for why it's split out that way. Yeah, but yeah, thanks, good question. And yeah, okay. So what we did before the break is we split off from our dates and our string representation of the date, just the month and the year. And the reason for doing this is now going to become perhaps a bit more clear because what we ultimately want to do is end up with our data in such a form that we have just a single temperature for each month and each year. So if we look at our data set, again, it's probably a good thing to do just because we have had the break. You'll see that we have whatever, 750,000 plus rows of data and a bunch of different columns now, including now we have this date column that we've just added and the year month DT column from running the examples in the Datetime stuff above. Now what we want to do is we want to end up with something where we have just a single value for each month, and the way that we're going to do that is we're actually going to create a new data frame to store those values. And in order to do this, we're going to use a function in our data frame called group by. So we could here, for instance, make a variable called grouped that's going to represent the way in which our data are being grouped together. And we'll then do data.groupBy. And then we give a column name. And in this case, we're going to give year underscore month. What this is going to do is it's going to form groups inside of our data frame where everybody or every one of the rows in the data frame that has the same year and month will be part of the same group. So we run this and you'll not see really any output written to the screen. But if we check out what type of data we have, we can see that it's now this data frame group by data type. So that's another Pandas data type we haven't dealt with before. And if we look at the length of this, we can see there are 601 groups. I think we had, what was it, 51 years of unique data in this data frame. And if you took 51 years and multiplied by 12 months a year, you get something pretty close to 601. And that is basically showing us that we have effectively one group for each month in the data frame that we have. Again, if we run .nUnique, that's our way to check to see how many unique values we have in the year-month column. There's 601, so indeed, for each year-month combination, we have one group. Now, we can explore this a little bit, so we can kind of check what's our names of our groups, which is basically the keys, by typing grouped.groups.keys, and this isn't shown on the course page because it produces quite a bit of output. But what you'll see is that we have a big dictionary here, and the keys are, for each one, a year and month that is in one of the groups. So 1906, first month of the year, so January of 1906, February of 1906, etc. And if you scroll on down to the end, you'll see that there's October of 2019 as the most recent group here. So we have now grouped our things together. Well, what can we do with that? Let's start with a specific month. So let's have a look at August of 2019. So 2019 for the year, and then 08 for the month of August. And if we take one of our groups, like group 1, we'll just give it some generic name, and we look in our grouped object, and we do get underscore group, and then month. So that's the variable that we specify here. We're going to get the group that is for the month of August in 2019. And again, our grouped object is what we created up here when we did our group by. So here, when we grouped everything together by which year and month we had, we then created this variable. So if we run that, and then let's take a look at what we have in group 1. We get back output here that looks like a Pandas data frame. And indeed, you can see that the year and month is 2019. There's 08 to represent August. And if we look at our time here, we can see that starting from the 1st of August at the start of the day, so midnight on the 1st of August, on down to the 31st of August at 23:50, we have data here. 2,220 rows of data in this case. This is all of our data for the month of August in 2019. So this has basically, by doing this group by sort of operation, created this set of these different groups where each group represents 1 month in our data set because we grouped by the year and month. So that's kind of nice to be able to see. And if we check out the type here of our group 1, indeed it is a Pandas data frame. So that means we can do all the data frame stuff we normally would be able to do, like calculate the mean value for the temperature and so on. Or we can calculate mean values for a bunch of different columns. So we have dir, speed, gust, temp F, and temp C as our columns. And we could basically go through and calculate the mean values for each one of those. So we could say, for instance, mean underscore values equals group 1, and then our mean calls. We could also put this in as a separate Python list, but it's a little bit more readable here if we make a list of what columns we want first and then just put that variable in here. But it's basically the same thing. Dot mean. And then if we take a look at what we get for mean values, we just print that out to the screen. So we're going to do group 1 and then put in mean calls dot mean, which means we should take basically for each one of these columns and calculate what the mean value is for our group 1, which again is August 2019. And when we print this out, perhaps the most useful thing or most intuitive to look at is the temperature in degrees Celsius of 15.888138 degrees, which is the average temperature for the month of August in 2019. And that looks maybe not quite as warm as we might like, but not too far off of what we would expect for the month of August in sort of later in the summer. So now maybe you're starting to get the picture here that we have a way to make these groups so that we can get one group for every month. We have a way to calculate an average temperature, for instance, by doing this dot mean for one of the groups. We just need to put it together now to fill in our data frame with the values for each one of these average temperatures. Again, we have a cell here that's filled in for us. What it's going to allow us to do is loop over all of our values that have been grouped together. So remember we saw the keys contained the year and month for each one of the groups. And then in our grouped object, we have basically those things. So we have the group, which would basically be the data frame that contains all the values for that month. The key is going to be that year and month combination, and we're going to loop over all of those. And we can print out, for instance, the key, and then print out the first rows of this group by doing group.head. And then again, we'll break it here so we just see one before we run through all, whatever, 601 of the groups that we have. So if we run this, you can see our key printed out to the screen, 1906-01. That makes sense. That's the first year and month that we have in our data frame from what we were working with earlier. And then when we do group.head, we see all these columns that are in the data frame. And this is basically the data that we have for the month of January of 1906. So the key is the year and month together, and the group is basically the data frame that goes along with that key. So we're close. Now, in order to take the next step, we got to do one or two other things. First off, we've got to create a place to store our data. So let's make a data frame here called monthly underscore data. And we'll just do pd.data frame. That just makes an empty data frame where we're going to store our monthly values. The columns that we're going to calculate things mean for, same as we did above. That's just copy pasted down here for the sake of simplicity. Now we want to iterate over all the groups, which in our case means we're going to use a for loop. And we're going to say for key, comma, group, in, and then grouped. So remember when we did this group by thing, we made grouped, and then we have our key and our group here like that. Just like we did above, we can calculate our mean values as a new variable. That's just going to be group mean calls, not mean clause, but calls dot mean. We just did this above to calculate the average for one of the groups. Now, we can add a key that contains our date information, because when we calculate the mean value, we're going to get the sort of mean, direction, speed, gust, temperature, whatever, but we don't know what year or month it is. So we could say, for instance, mean values, and we could add in here year underscore month equals key. Because when we go through this for loop, the key is basically the year month string we have from our data frame. So we'll add a column or add a value to, this is basically a Pandas series. So we'll add a value to the series that contains the year and month. Then we've got to do one kind of funny thing here, which is to transpose our data into a row orientation. Right now it's sort of like a vertical column, so we've got to flip it on its side like a row. So we can say row equals mean underscore values, to underscore frame. So this will actually convert it to a data frame, and then dot transpose. And I think I've got to give the parentheses here. This is probably not entirely clear to you why we need to do this, but if you think about it, we have essentially a column of values where every time through the for loop, we calculate the average temperature stuff, the average wind stuff, and we add the key in there to know what year and month it is. In order to put this into a data frame, we want to flip it on its side because essentially we want to have a column with the dates. We want to have a column with the temperatures. So that's what this transpose operation is doing. It's basically just turning our data frame from being vertical to being on its side, or actually it's taking our Pandas series, making it into a data frame, and then flipping it onto its side. So it's a little bit perhaps unclear. There used to be simpler ways to do this in Pandas, but they changed the way in which this should be done. And so now things are a little bit kind of more complicated than they might have been in the past. But finally, we can add our new row to the monthly data frame by doing monthly data monthly underscore data equals pd dot concat. So this is a concatenation, or sort of like it's somewhat similar to appending, but you basically just adding together two data frames. And then we give a list of the data frames we want to concatenate. So we have monthly underscore data. First time through here, monthly data is going to be empty. And then we have the new one that we created in the line above called row. And finally, then we'll add in this ignore index equals true, because the index is for row, for instance, going to be 0 every time. So if we fill it in with the index values, it would be a bit confusing. So we'll just ignore the index, which means it's going to start at the top at 0 and increase by 1 as you go down row by row. A lot of stuff happening here, but we've built this up sort of step by step to get to this point. And if you run this cell, it takes a couple seconds to run through. In principle, it should have created our new data frame called monthly data, where we have an average temperature for each month. So just to kind of review what's here while people are still finishing up typing, basically we're creating our empty data frame first. We've got a set of columns where we're going to calculate the mean value. Then we're going to make a for loop that lets us go through each one of the groups we created when we grouped by the year and month. So every group that has the same year and month will be sort of those rows of the data frame will be grouped together. We calculate the mean values for those for a given row. We add a key or a sort of label for the year and month to our Pandas series. Then we do this kind of conversion thing where we flip the series onto its side to make it a data frame. And then finally, we add that new row to the monthly data frame. Are we good? All right, let's have a look. So if you haven't jumped ahead already and taken a look, what you should see here is now we have a data frame for monthly data. You can see year, month, and each one of these year, month values is listed only once. And for each one of the years and months, there is now an average temperature. So we can see, for instance, in 1906 in January, that the average temperature was minus about 3.6. A little bit warmer in February, colder in March, and then started to warm up as spring started to arrive after that. Okay, so now we've gone through the whole set of steps of going from our data frame to renaming columns to doing this sort of data aggregation. And of course, we could find the means of all the columns at once. There's another way to do that fairly efficiently by just typing grouped.mean. If you run this, it takes a moment, but this would give you mean values for each one of the all the columns. So you can do the same operation we just did above similarly here. And we could, for instance, store that and then pull out just certain columns that we care about. But that's just to basically show you. Our last task here is to detect which months were warmer than average. And in order to do this, we want to first figure out, well, let's just get April for from our data that we have, because we don't need the any other months. So let's just get our Aprils, and we can do this as data, and we'll say we want the data from our data frame where the data month equals 0.4. So we want to pull out just the rows of our data frame where the month is equal to 0.4. We created that column earlier, and now we can take advantage of that. So we run that cell. That should give us only the month of April that's left in our data frame, or it's going to be in our new data frame called April's. In addition, we can take only certain columns that we care about. So we don't care about the wind stuff, so let's just get the station number, temp F, temp C, and then the year and month. So we just run this cell here. Then if we do something very similar to what we did before, we can make our groups. So we could say, for instance, grouped. Again, you could call this whatever you want. It doesn't need to be called grouped. But we can do April's dot group by, and then by equals, and year underscore month. So this is basically the same operation that we did earlier, but now we're going to do it just for the Aprils. So we run that one. We make a new set of groups that should be only for the month of April, but it should still be for each year that the separate group exists. Then we can do something like monthly underscore mean equals grouped dot mean. So this will calculate the mean for all the columns in our data frame, but that's fine because really what we care about is temp C, and well, for each one of the groups, year month won't be varying, so you're going to get the same value back that you had. So our grouped dot mean in this case should calculate for a given April what the average temperature is. Which means if we look at monthly underscore mean dot head, we should be able to see in here April of 06, April of 07, April of 08, etc., and the average temperature for that month. What this means now is that we can basically figure out from here, just by sorting, which month of April was the warmest on record at this station. If we sort it in order so that the temperatures for temp C column are descending, they are the average temperature for that year in April. And right now they're sorted by the year and month in ascending order, but if we do this as a descending sort, that should tell us what the warmest April was on record. So we could do monthly underscore mean dot sort underscore values. And then here we're going to say by equals, and we want temp underscore C. We could sort by temp F as well. It doesn't make a difference, right? Because they're converted from the same thing. But we want to set ascending equal to false. So we want the highest values at the top, not at the bottom. And we can also do dot head and then 10. So this will just give us the top 10 years in terms of temperature for the month of April at this station. And again, I think this is the station from Tampere. Sure enough, lo and behold, the month of April of 2019 was the warmest on record at this Tampere-Pirkkala station. Perhaps surprisingly, the months of April in 1990 and 1989 were the next two warmest after that. And then we have 2011, 2004. So this kind of is a little maybe different than what was expected in the sense that although temperatures on average in terms of global temperatures have been warm and increasingly warm over the last decade especially, of course, individual weather stations, individual locations in different places will have different situations. So in our data analysis here, we can see not only can we do this sorting and this kind of data aggregation stuff, but we can also see things that might be somewhat surprising. Perhaps not that the month of April 2019 was so warm, but that there were other years already back in the late 80s and early 90s that were also quite warm, which might be a bit unexpected. Are there any questions at this stage? I know I went a little bit quickly through this grouping stuff. I will say that this is perhaps something that you may want to revisit on the course page to just look over before you start working on the exercise this week, because we'll do grouping in this week's exercise, and at least for me, when I was learning this stuff in Pandas, it took me a little while to kind of understand exactly what's going on. So I'd say it's worthwhile to look at that. All right, I think maybe I'll spend something like 5 more minutes here to finish up the last little piece of the exercise, and then we'll switch gears to finally get away from our data analysis task and learn about a few other things. But I mentioned at the beginning that we can do this same analysis with multiple data files, and this is perhaps one of the places where working with pandas becomes most interesting, in the sense that we can repeat what we've done for a single data file many times quite easily. So what we have here is a cell that's already got everything filled into it, and you can see there's a bunch of different stuff here that's basically just the set of steps that we have done in our analysis to be able to do our kind of sorting to figure out which month of April, for example, is the warmest on record. You can see we're loading the data file here like we did earlier, renaming our columns like we did earlier, printing out some information to the screen, creating a new column for temperature in Celsius, applying the function to convert temperature from Fahrenheit to Celsius, doing our date string creation and then string slicing operations. You'll note here one difference is that we're taking only character like starting at 5 instead of 4 for the month, because if we're looking at the month of April, we only need the 4. Then we take the subset of columns we care about, we make our groups, we calculate the monthly mean, and then print the information to the screen that we have here. This is essentially everything we did above. So all you have to do is basically run the cell here, and you should see that for this station number, which is the Tampere Pirkkola station, here are the warmest month of April on record, and there's 2019 at the top. And you can see, for instance, here that our station number is what's listed at the beginning of the data frame, and we can then take advantage of the different station numbers we have to then be able to do the analysis on multiple data files, because each data file in this case is for a given station number. In order to do this, we're going to use a library that is called, I don't know if it's glob or globe in terms of how it's pronounced. I think globe sounds nicer, but glob might be the name. I tend to think of it as globe because it's basically like searching for things. So you can kind of give a file pattern and it will find files that match that pattern and do something with them. So if we import the globe library, it's built into Python, it loads in very quickly. We can then create a file list, file_list, using globe as globe.globe, and then in parentheses we give, in this case we'll give a raw character string, so it starts with an F and an R, and then we do /home/javian/shared/data/L6, and I think then we can say /0*txt. This might look a little bit alien, but what we're doing here is we're giving the location, which is the absolute file path to our data files in this exercise, or this lesson rather, L6. We're giving this as a raw character string, which is why the R is out in front of here. There's reasons for this we don't need to get too tied up in, but some characters like slashes are sometimes treated as a special character. Star is also one that's treated as a special character and can do different things. So we're using a raw string here, which will basically just take this exactly as typed in rather than trying to make the star do something special. But this will basically match any file that's in this directory, this shared data L6 directory, that starts with the character 0 and ends in txt. Let's have a look at the file browser for just a second here. If we go back to our data files, you'll notice that these data files here, this is all our data for the stations. They all start with a 0, they all end in txt. These will be found by this file list. You'll notice our metadata files, here's one that starts with a 3, here's one that starts with a 6, and another that starts with a 6. They also end in .txt, so if we just did star.txt or star.txt, it would give us all these files, and we don't want to have the metadata files in our set of files we're processing. So we do 0 star txt. Star is basically what's called a wildcard character, which means anything can be put in between here. As long as the file starts with 0 and ends in txt, it will get added to our file list. So we run this one, and if we run the cell underneath it, you can see number of files in file list is 15. And if we print out the file list, what you see is the path to one of the data files that we're working with. This is the full file path to this data file. And then it's a Python list that basically contains full file path to all of the data files we have. So if we did this in a for loop where we said for fp in file list, print fp, you run this and you basically get each one of the data files that we want to work with. So now we know already from what we did above how to figure out what the warmest temperatures are in the month of April. Now we have a way to go through multiple data files, and what happens in the cell below here is essentially we wrap this whole set of steps we did above in a big for loop that allows us to go over each one of the data files, load in the data file, do some calculations, and print the information out to the screen. So everything that's in here, all of these lines, are the same things that we've done above already. It's just all put in sort of a single cell as a set of steps, one after the other, to do things like read the data file, rename the columns, make a column for the temperatures in Celsius, make a string version of the date, split that string, find the Aprils, make the groups, and calculate the mean temperature. All that stuff is things we've already done. We've just now wrapped it in a for loop that will go through each one of the data files and do that. So that means we should get the warmest April from each one of the different stations here by running this cell. And if you run it, you'll see output that starts getting written to the screen. So for this station number, 28360, we can see that actually the warmest April on record there was in 1937. There's 2019 was the 5th warmest at that station. Second warmest at this one, third warmest here, third warmest here, not even in the top 5 at this station. 5th at that one, second, 4th, warmest. Okay, that's 29440. That's the Tampere Pirkala station we were working with before. But then there's another one where it was the warmest, another here. Anyway, you get the idea that you can see from this, we've now gone through 15 stations of data, done quite a bit of data analysis with only adding 2 lines to what we had already done before. That's one of the reasons why doing stuff in Python is useful, because you can take the sort of workflow you design and extend it to multiple files in as little as, in this case, basically 2 lines of code. That's essentially the end of what we have for today's lesson. Are there any questions? So this is the Python part of the lesson, I should say. I don't want to sort of have you get up and leave yet because Kamyar still has some things to say. But yeah, if there aren't any questions, you'll get practice doing this very similar kind of thing in this week's exercise, so you'll get a chance to rehearse that. But at this point, I think it's probably good for us to have a look at some of the other notebooks in this week's lesson. And I think we'll start with the notebook on errors, and we'll transition so Kamyar can tell you about errors and debugging and some other things.
Okay, so hi everyone. We are taking a little bit of break from Pandas, so we are looking at a bit different things. It's still, it's more like general level Python, also relevant, of course, when working with Pandas. Yeah, so let's start talking about errors. So this is something that you have probably encountered already many times when working and following us during the class, and also when you're doing your exercises. It's something that it's annoying when you're running a code and you see this red text, seeing that you have some kind of error in your code. But it's a very useful feature of modern programming languages, including Python. So it gives you some idea that, okay, there is something wrong in your code, and now you have the chance to fix that. So we have different kinds of errors. And today we are going to see some examples of different errors that there's a long list of errors that you can see in Python, but we are going to go through some of them that you're more likely to see now working with Python at this level. Yeah, so let's start with one example and try to get some error to get some idea what we are talking about. So you have written a function, you have written a piece of code that you want to convert wind speeds from kilometers per hour to meters per second. So if you run this code, you will get error. It's a syntax error. It's telling you that there is unterminated string literal. And the reason is that, well, when we are printing the output here, when we do the calculation, when we are printing the output as a F string, this is a string character. So we have seen this many times, that once you start a string character, you have this quotation mark at the beginning, but you also need to close it. So when you don't close it, you get a syntax error. So syntax is the way you talk to a computer and it's specific to a programming language. So in Python, you have certain ways of writing your code. And if you don't follow that certain way, you're going to run into error. So in this case, we have an error because we have the quotation mark here, but we didn't close it, and Python doesn't like that. So it runs into an error. So this is a typical view of what errors look like in Python. So let's have a closer look to see what kind of information we can get from them. So as I said, these are useful things because again, it points you to the place where you have the problem in your code. So here it's directing you to the cell. Well, we are running this in Jupyter Lab in the notebook. So we have cells. It's telling you that, okay, you have an error in the cell. And then you have the line number. So it's telling you that in line number 4, you have an error. And then it gives you the type of the error. In this case, we had a syntax error and some explanation about it, some details about the error. So this is quite useful information. You know what type of error you have the location, the place where the error has occurred. This is not so accurate. It often gives you a very good idea where the problem is, but it may not be always correct. For example, you might get an error at a certain part of your code, but the real reason for the error might be a bit earlier in your code. So, but it gives you a good starting point where to look for the problem. Yeah, so let's try to see another example, get another kind of error here. So here we are working with the same function. So we are converting the wind speed from kilometers per hour to meters per second. So the input of the function is a number, or should be a number in kilometers. But what has happened here is that the input is a text. You can see it's 30, but it's in quotation marks. So for Python, this is a text. This is a string. So what happens when you run this piece of code, you get, well, we fixed the problem we had earlier with a string. So we have closed the quotation mark here, but now we have a new problem, and that is the input is not a number. So this is problematic for Python. We have seen examples of this before during the course, because here we are multiplying now a string by a number, and that's a problem because Python doesn't know what to do with that. So what you're going to get is another error called type error. It's just telling you that the operation you're performing, the data types you're working with are not compatible. So you cannot do that kind of operation, which in this case is just multiplying the numbers. Yeah, so in this course we are using Python version 3.10, and this is not the newest version. There are newer versions, but what has happened in recent updates of Python is that there have been some improvements in how the errors are handled. Actually, in the traceback you get, when you have an error, there are a bit more details, which makes it a bit more helpful to find out what's wrong with your code. So, as I said, there is a long list of the kinds of errors you can get in Python, but a few of the most common ones you can see here. So we have index errors. This is something that you have probably seen when working with lists in Python. So we have an example here. We have a list with 3 European cities in it. So if you try to get the output for the index number 5 of this list, you're going to get an index error telling you that this is out of range, because obviously in this list we have only 3 items, so we don't have index 5. So this is an index error. Another common type of error that you see often when coding is name errors, and that basically means that you're trying to access something. It can be a function or a variable that you haven't previously defined. So it's for the first time you're trying to call it, but you haven't defined before. So you're going to get a name error. So in this case, we don't have a list with this name. So when you try to call it, you get a name error that this is not defined. If you had defined it in advance, then you wouldn't have gotten this error. So this is something that happens if you haven't defined, or sometimes you might have a typo. So you have defined a variable with a name, for example, stations, and then when you're using it, you forget that it was a stations. You just write a station, and you will get a name error. So this is a common error that you will see, and very often it's because of a typo if you have defined it before. Another kind of error that we have seen a lot working with Python is the indentation error. We have seen already in multiple cases when working with functions or when we work with for loops, we need to indent our text correctly, otherwise you will get an error. So here we have a couple of examples. So here we have a for loop, and then the print function is just somewhere in the middle, so Python doesn't know if it is inside the for loop or is it outside the for loop. So you're going to get an error, indentation error, telling you that this is wrong. Then a second example here, you have a for loop, then you have the colon at the end, so Python expects you to add some indentation before you write what is inside your for block. But if you don't do that, you're going to get an indentation error. And one last example here is the type error, which we saw earlier, and that basically means that whatever you're doing with data types that are not compatible. For example, if you're multiplying a string by a number, those are not compatible for this kind of operation, so you will run into an error. Yeah, as I said, there's a long list of errors, so you can read more about them. There we have provided some links on the course website, so you can read more on that. But if you have any questions here, you can ask. If not, I will continue with the rest of this lesson, so we will still have some time to go through the exercise and talk a bit about the final assignment of the course. So yeah, so another useful thing to use in our programming when we are coding is using assertions. So this is based on the concept of defensive programming that is not only limited to Python. It's a programming concept. So it means that you want to produce codes that are reliable, they're safe, you don't have problems with it, and you can predict the outputs that you get from your program. So this is the basically the idea behind defensive programming. You're prepared for all kinds of inputs and what kind of outputs are produced based on them. So this is important for producing codes that are more comprehensible, codes that are more secure, so there's no like security hole in it, and you have more predictable outcomes, which is usually what you want. So one of the ways of being a bit more prepared with the kind of outputs we get from our code is using assertions in Python. So with assertions, it's a way of asserting or ensuring that the values being used in your script are suitable for the kind of task that you're going to perform. So let's look at this example again, the function where we want to get a number, which is the kilometers per hour, the speed of wind, and we want to convert it to meters per second. So with assertion, well, you want to make sure that, okay, I want the number to be positive. So you can add a line of code here inside your function, and it's very simple. So assert, and then you have a condition. So you're saying that, okay, I want the condition is that the speed is greater than 0. So you don't want negative number. So this wouldn't, if you don't put this assertion, this would not cause an error because it will just multiply whatever input you provide and give you some output which may not make sense because we don't want to have the speed in as negative. So with this assertion, you make sure that the input is going to be positive. So let's see what would happen if you provide a speed that is negative. In this case, we have minus 27. So because you have added assertion, so you have put this line here that assert speed greater or equal to 0. Because of that, you get an assertion error. So it tells you that, okay, you were supposed to provide an input that is greater than 0. You haven't done that, and that's the error you get. So to make this a bit more informative, you can also add some kind of text. So here in front of assertion error, you can see that there's no text because we haven't provided any more information. So when you are defining your assertion here in this code, so we can also specify some text. So you just put the condition, then there's comma, and then there's this string. So you say when the speed values must be positive or 0. So in this case, this time the error will have more details. So you will see, okay, we have an assertion error, and this is the text. So the problem is that the wind speed was supposed to be greater than 0. So by now you probably know the way you should write assert. It's quite simple. So it's a keyword assert, and then you have some condition. We have worked with conditions a lot during this course. And then optionally, you can add this text after the comma, so you will have more details when the error is raised. And in some cases, you may want to have more than one assertion. For example, in the same example, you might want, you want the numbers to be positive, more than 0. You also may want to make sure that, okay, the inputs are numbers. So no one can, for example, provide a string because it wouldn't make sense. For example, if someone, instead of writing a number, you would put just the string dog or whatever, you want to raise some assertion error. So in this case, you're getting an error because the values must be numbers, and that's how you have defined it here. So you have two assertions. The first one is making sure that the values are number, and the second one you're checking that they are 0 or positive. But this gives you some idea how this works, but this is not a good example because the idea of assertion error is that Python by default gives you a number of errors, many of which are very informative. So if you have that working already, you do not have a good reason usually to make also an assertion error. In this case, if we didn't have the assertion error, we would have gotten a type error anyway because we are multiplying the string dog by a number, so Python wouldn't do that for you. So basically what we are doing is not very useful. What you want to achieve with assertions is what is a bit more invisible. So in this, like the earlier example we had was better. You don't get an error if the kilometer value is negative, so Python wouldn't say it's wrong, but the output wouldn't make sense. So you put an assertion to make sure that, okay, you don't, so your output makes sense. Yeah, so just one thing to note here is that the idea of assertion, like using assertion in Python, is more like for debugging phase, because this is not going to, if you share your code with someone or some user, it's not going to stop them from making those mistakes, because this basically raises a flag, and in Python you can, there is a way that you can, it won't stop you from those making those mistakes. So it's just something to make your code better, and also in the debugging phase, you know how things work. So if you want to stop users from making those mistakes, there are other ways, stronger ways of doing that. But this is a good practice. This is a good thing to do in your coding, to make sure you provide good inputs and things, and to see that things work well. Do you have any questions from assertions in Python? If not, we proceed to the last part of today's lesson before we talk about the exercises. And that's about debugging your Python code. Well, it may not be the funnest part of programming, but probably you end up a lot of time debugging your code. As a new programmer, you might run into a lot of errors, but this is something that will always be there, even if you're more experienced. When you write things, you might make mistakes, you might have typos, so you run in different kinds of errors. But there are a few steps that you can take to make this a bit more smooth, like this debugging process. And here we have a few advices for you. So one of them is that you should test your code with known outputs first. So if you're doing some kind of calculation for a large data set, we saw some examples today. So it's good to run the program first for a small part of your data, so you can see that the output is correct. So for example, if you're doing similar calculations to what we did today, like calculating mean temperatures and identifying the anomalies in data, like finding what is the biggest difference in which months, for example. So if you do it first for a smaller part of your data, you can see that, okay, does it work well? And you can just see that, are the calculations okay? But if you do it for your whole data, it might be hard to say if it works well. So it's a good practice to test it first. If you do some complicated calculations, to do it first with smaller portion of your data. You should make your code crash quickly and regularly. That sounds crazy, but it's a good practice actually. So if something is going to fail in your code, if there is a problematic area, it makes sense to make your code crash quickly so you can just test many times and try to fix things. So imagine if you run a program and you're working with a huge file, huge data, you do many things, and the code might take 30 minutes to run, and then you get the error. So imagine if you're trying to fix that error, and every time you fix something and you want to test it, you have to wait 30 minutes to get that error or not. So this is not advisable. You should try to get that error as quickly as possible, or you should try to make the data smaller until you can find the error and fix it, so you don't have to wait for a long time to reproduce that error every time. And it's a good practice to make small changes and then try to track them. So if you're programming, like you make some first version of your code and then you add features and functions to your code. So it's good to do it gradually and make sure that things work. Then if you add something and it breaks your code, you know that, okay, what I just added is the reason for problem. But if you write so many things without testing and then you get the error, it's hard to know, okay, which line of code, which part of my code is the reason for this error. So with GitHub, for example, it's not a good idea to commit every little change you make, but you change regularly enough. So whenever you make bigger changes and you have a stable version of your code, it's a good practice to commit that change to GitHub. Yeah, so that was it for debugging and finding errors in Python. Do you have any questions from this?
Yes. Okay. So last couple things here in our last minutes of class today. So first off, exercise number 6 is now up and available on the course page. And in this week's exercise, well, it's perhaps not a surprise that we're going to be doing some data analysis with pandas. Basically, we have 3 different steps that we're going to take. And in each one of the problems, we're going to conquer one of those steps. Problem 1, you have to read in a tricky data file and explore its contents. Problem number 2, you're going to convert and aggregate data from daily temperatures in Fahrenheit to monthly average temperatures in Celsius. This should hopefully sound familiar after today's lesson. And then in problem number 3, we're going to calculate weather anomalies by comparing monthly average temperatures to a long-term average. That part I will spend a little bit of time to explain just because I think it's worth making it clear to you. Anyway, you'll see on the input data that, for instance, here you can take a look at the data file that we're working with. It's not going to render in GitHub because it's too big, but this is the file format, so it's a little different than what we saw before. We do have fixed width columns, so that's one thing you can kind of have in mind, and you can find a hint about dealing with this data file as well on the course page for the exercise 6 hints. But the thing that's new that we haven't dealt with before here is this nice line of hyphens that separate the headings from the values in the data file. So you have to find a way to deal with this in Pandas. And again, I'll remind you to take a look at the hints for exercise 6 on the course page for how to deal with this issue. There is a solution that exists. But in essence, if we take a look here, we have one notebook that contains 3 problems together. And what you can see here, for instance, is the tips to have a look at the exercise hints at the top, but the things that you need to do here to read in our data file such that we skip the line with these hyphen characters and we convert the -9999 to be not a number values. That's essentially what you have to do in the first problem, read in the data file. Then once you've done that, there's some different things where you can calculate some different, well, I don't know, kind of typical reading in the data file type stuff. So how much missing data do you have in the T average column, in the T min column? How many days of data do we have total? When's the first observation? When's the last observation? What's the average temperature? And then there's some other ones in here that you can calculate as well. Problem 2 is about calculating the average monthly temperature. So this is more or less like what we've done in today's lesson. And I won't go into this in too much detail other than to say that you just have to take the data file we have and calculate the average temperature for each month in that data file. That's, I think, enough said there. But problem 3 is the one that usually is the most tricky. And part of this, I think, comes because it's maybe hard to understand in some sense what exactly you're meant to do. So the idea here is to calculate a temperature anomaly. And the temperature anomaly basically is a difference between the temperature, for instance, in a given month, compared to the average month over some reference time period. So in our case, you could take, for instance, the month of January of 1994, and you could calculate the average temperature for that month, and then compare that to the average temperature for all Januaries in the years starting at 1952 and going up to and including 1980. So this is kind of like your reference of what is a normal temperature in January at this weather station. So you're going to calculate things that are different here and put them into a data frame called reference temps, where you have one temperature for each month of the year for a longer, like whatever this is, almost 30 years period. So you say over those 30 years, what was the average temperature in January? And you should get a number that looks like this. What's the average temperature in February? You should get a number that looks like the one that is shown here. When you want to calculate this temperature anomaly, you then go through and pick a given year and that month, and you say, okay, what's the difference between that month's temperature and the reference temperature? So that way you can tell, is it warmer than average or colder than average, where the average we're referring to in this case is this reference temperature. Does that make some sense to you? Okay. Historically, it's been the case that it hasn't made sense to everyone, so you will also find in here a little bit more of an explanation with some graphic that's explaining what the different data frames are that you should create and what the values are that should go in there. Hopefully this helps to make things more clear, but please read through problem 3 carefully before you start working on it. It will save you time if you read everything here, because I think as best as possible, we've tried to explain clearly what exactly it is you have to do. In the end, you're going to end up with a new column in your data frame where you have this temperature difference, or the anomaly. That is the difference between the temperature in a given month minus the reference temperature for that month in the 30-year reference period. So that's the part 2 of problem number 3. There is a part 3 here where if you would like to practice using ChatGPT, you can. It is again optional, so it won't count in terms of points toward the exercise, but if you want to just test out and see whether you can get ChatGPT to produce code like what we need for this exercise, you can do that. And there's not so much structure provided here, but you're told, for instance, that you should create a data frame called AI reference temps. That's where you're going to store your reference temps that are produced by ChatGPT. And then you'll add in a new column to your monthly data frame called AI ref temps, which is similar to what you did or would have done above, but just to differentiate that from the version that's already there, and also AI underscore diff to have your new column that has the temperature differences or the anomalies. Like before, you're basically asked to provide a prompt, so what it is that you asked ChatGPT to do, and then the output code that was produced there. And you can do that and then run a couple tests. And similarly then, if you need to have extra prompts, you can list those additional prompts and the additional code that it produces down here. And then you can give some comments on how that all went. There's one other thing I want to point out here, and that is on the course page now. You can go and see that the final exercise assignment description is available there. We're going to go over this more next week because there's still a few things you need to finalize in the final exercise, but just to give you a picture of how things look, I thought I would just show what the final exercise looks like. You'll notice that the GitHub Classroom link is not working right now. That's of course deliberate because we're still modifying the exercise description a little bit, so we don't want you making your copy to start working on it until everything is finalized. In this case, just so you know, the main difference is we want to include some description about in what way you can use these kind of AI tools like ChatGPT in completing the final exercise. The plan that we've tentatively discussed is that you would be able to use ChatGPT, for example, but we need to still add some description of how you would describe what you've done and also update the assessment to include that because it's not in there currently. But if you're curious, you can go and see, I think, let me just double check if this link actually works. It should. The link from the course page will take you to GitHub so you can see the description of the final exercise as it stands right now. Again, this will be updated by next week, so we'll give you some more information there. But things like this due date are not likely to change, so you'll notice that this is into period number 2, that the due date for the final exercise is like that. The idea is that we want to give you a couple weeks to work on this because it's a little bit more open-ended exercise. But essentially, you're going to do the same kind of analysis that we've done in basically parts of most weeks of the course with the exercises. We're going to deal with a data file from Sodankula where we have over 100 years of climate data, and you're going to go through and basically calculate the temperature anomalies and do some plotting based on that in this exercise. Notable differences here, a couple things. One is that you're working individually, so not with your partner on this. This is the one place where we kind of have to be able to check on how you're doing as an individual with the things in the course. Of course, you're still welcome to talk with your partner, but what you turn in is should be your work. We provide general instructions, which is basically what's down below here, instead of a well-structured notebook. So actually, if you look at the notebook for the exercise, I think I may have shown this already last week. This is it. So there's nothing there. It only exists like this just to make sure that everybody has the same notebook with the same name, because that makes it easier for us to check them. But it's totally empty, and the exercise itself is worth a bit more, so in terms of the total grade for the course. What you're going to end up doing is producing a plot where you have a set of these 4 plots, where you have one showing the temperature anomalies for the winter, spring, summer, and autumn over the whole range of dates that we have here. You've got a data file that looks like the one you're working with in this week's exercise, so good to remember that. And it's important to note that the temperature average column is missing quite a lot of data, so what you'll have to do in this exercise is you're going to have to calculate an average or an estimate of the average based on the Tmax and Tmin and fill in the values to the temp average column, but you can find more detailed description about that here. I think for the moment, I will just say that basically this is going to combine parts of what we've done throughout the course, and we can come back to the description next week in just a little bit more detail after we have added the piece in there about how you are able to use AI tools, and also when we've gone through the lesson about the plotting. So you can see, like right now, if we haven't done anything about data visualization, it might not quite be clear like how you're going to end up with a plot that looks something like this. But the overall point is you can go to the course page and you can have a look if you would like to see what the exercise looks like for the final exercise in the course. This section is going to change about the description of how you're able to use these large language model tools like ChatGPT. Are there any questions about exercise 6 or the final exercise? Okay. So if not, we'll see you back here in a week for our final lesson on data visualization. And as always, please feel free to drop into the exercise help sessions on Thursday and Friday. The course assistants have been expressing their desire to see more people there, and they'd be more than willing to help you. So please feel free to drop in. And we'll see you next week.